Hi, welcome to the final episode of Solid Principle course, Dependency Inversion Principle. If you're aiming to have a modular project, you need to understand dependency inversion and some fundamental concepts such as high-level modules, low-level modules, abstraction, loosely coupling, and all of this will be covered in this video, and eventually you will be able to apply this principle on your project. Let's look at the definition first. It states that high-level module should not depend on low-level module, but on abstraction. Additionally, abstraction should not depend on details, but details should depend on abstraction. It's a little bit of mouthful definition. Let's break it down and understand these keywords. So what is high-level module? Those part of your code that contains the core business logic. For example, your application has a search functionality and you define a search use case for that. This use case class is part of high-level module. Another example could be a trading application. The trade functionality could have its own use case class, and this use case again is part of high-level modules. And obviously, these use case classes doesn't change often. Now let's understand the low-level modules. Those area of your code that contains the implementation details. I mean those classes that say how to implement this solution. What technology shall we use? What database should we use? Should I use file or share preferences? Room database or realm? This kind of class utilize tools or any other framework related should be in low-level module. Abstraction is about hiding concrete details and defining a contract instead. In Android, we can achieve this with interfaces. We can create an abstraction layer by creating some interfaces and having their own concrete implementation. And as it mentioned in the definition, high-level module or details can depend on this abstraction layer rather than concrete details. Based on what I said so far, imagine there is no abstraction layer and different parts of application are depend on the concrete implementation, and that will call tightly coupling, and there won't be any loosely coupling to follow this principle. On the flip side, if we consider abstraction layer, we can depend the high-level modules details to this abstraction layer rather than concrete implementation. Make this design loosely coupled. So let's continue with an example to understand dependency inversion better. Based on the definition, to violate dependency inversion, I want to depend my high-level module to low-level module. First, I want to create a search use case class and depending it into a low-level module. I created remove search data source as a low-level module class. This class interacts with backend, and we may use some tools like retrofit. And search use case, which is considered high-level module, is depend directly to remove search data source, which is the violation of the IP. Now I want to correct this implementation to follow dependency inversion. First off, I need to create an abstraction layer. As you see, I created search data source interface and depend my search use case class into this interface and not directly to the concrete implementation. This way we make the implementation more flexible and follow dependency inversion. This way we can define more search data source classes, for example, local search data source, and we can swap them easily. One more thing we need to consider, we have a search view model class and we want to use this search use case in that class. But based on the definition, detail should not depend on high-level module. So to fix that, I need to create another abstraction for search use case and depend my search view model to that abstraction and not directly to the implementation. Now the implementation is completed and we are following dependency inversion principles. Before using search use case class, I would like to organize my code base into different modules. This is the look of modules after organizing the implementation. I defined a data module, domain module, and presentation. In the data modules, I included data source and the use cases. The domain module considered the abstraction layer. I included the interfaces, search data source interface and search use case interface, and the domain objects. Within the presentation layer, I have search view model class, and I've used search use case interface in search view model. So let's look at the code structure from bottom to top to see how these dependency inversion apply. We have the search view model class, which is considered the details, and we are depend on an abstraction layer, which is the search use case, and the implementation of this search use case depend on another abstraction layer, which is search data source. And this search data source can have different implementation, local search data source or remote search data source. And that makes the code base flexible and many other benefits. DIP is one of the most powerful object-oriented design principles. It produced reusable code, made the code testable. It helped the separation of concern and designing modular project. Additionally, make the maintenance easier in long term. That was all about dependency inversion principle. Hope you found it useful. We reached to the end of Solid Principle course. I did my best to share my knowledge about these 5 principles clearly. If you have any question about principles, just write it down in the comment. And if you have any comment or feedback, we are happy to hear.